Hi and welcome to the new video of Code Execute. Today we are going to discuss about system design of an e-commerce application. So during this video, we are going to discuss about functional requirements, non-functional requirements, and how do we handle the number of and estimates. And then we are going to look at how the high-level design will look like. And we are going to talk about the database design. And then we are going to talk about API design, and then we'll go into low-level details. So firstly, to start with, we have in front of us an e-commerce application, right? So to start with, what are the functional requirements that we have? And what are the non-functional requirements that we have? And what are the estimates that we want to handle eventually? And what is going to be a database schema? What is our database schema is going to be looking like? And what is our API? What are our APIs are going to look like? That is API design. Then we are going to look at a very high level architecture, which is a high level design. Then we are going to talk about low level design. So functional requirements. The main requirement that we have is we have an e-commerce application, and we are going to have users coming in, and they will be able to buy products, and then also it could have a persona of a user being a seller, and they could also be sell the products, right? Buy and sell the products. And there are more layers to this use case, but these are the basic ones. We are going to go deeper into the use cases as we go forward. And non-functional requirements are, we are going to have very less latency, and we are going to have very high availability. And we are going to have a failover, because with high availability, which means that we are going to have a failover scenarios where we have a way to ensure that our application is very highly available, and we're going to have high consistency during our tenure. As part of latency, we are going to take care of multiple things, like making things asynchronous and so on and so forth. But for user, it's all comes down to latency, and we are going to have performance. We can say performance falls a little bit into latency, but yes, we can discuss a little bit further. And yes, so initially, let's talk about now estimates. We eventually could have 1 billion events that could happen in a day, because it's a high scale e-commerce application. It can be used by any user in the world. So it could 1 billion events a day, which means that we are going to have 12K events per second, 12,000 events per second. That's we are going to handle. And yes, that is the estimates and database schema. Before I wanted to jump into database and API schema, I want to talk a little bit about the high level architecture, because in e-commerce, because of the vastness of its use cases and the large scale that it has, high level design and the individual components of the system are very important. So I'm going to talk a little bit about the high level design. So let's put a picture down here. So let's say we have different kinds of clients here. It could be mobile application, and it could be browser window. And these are all the clients that could connect to our server. And front facing of our server will be a load balancer. That basically a gateway. We're going to have a gateway that will take care of multiple things like load balancing, routing, caching, and to some extent authorization and authentication also can be taken care by API gateway. So once we have API gateway done, we have it moved into different. It can be routed to different services. The main components that we are going to have is user service. And because when it is e-commerce, we are definitely going to have a catalog service, which contains all the inventory data, and we are going to have a search service, because users should be able to search the items and then get listed that based on the catalog items that we have. And then we should be having a payment service. Before I talk about payment service, we actually have cart service, because once user starts his shopping in the e-commerce, he'll move on to search service, and once he selects an item, he moves on to cart service. And then comes the payment service, of course. And then we also have multiple other things called notification service and so on, so right. So all these services are what we've done is we have broken down our system into multiple microservices. So the idea is to have a microservice architecture here rather than building a monolith. So once we have this, all of these services need to be connected to a message service bus. So the reason we have chosen a message service bus is that If we eventually chose a request response architecture, we are going to increase the latency because it's a large scale application and we want as less latency as possible. So we are going to choose a message service broker here. Once you have a message service broker, all the microservices will have the data that they are going to be communicating with inside the message. We can always have, so the underlying message broker could be Apache Kafka or some other RabbitMQ, any message broker, but I tend to go with Apache Kafka because of flexibility that Apache Kafka provides, and it has so many ways inbuilt that it provides to be able to scale our system. So I'm not going to put down any product as such. I'm going to call it a message service, message broker for now. But yes, the idea is to make, so we are eventually going to have a publisher subscriber model here because all these services could be publishers and subscribers to the message broker that we have, and that's how they communicate with each other. So let's talk about data flow a little bit. As a user comes in and has a persona of buyer, user comes in and his API call, then user tries to search an item in e-commerce website to start as a beginning step. So the call goes through API gateway and then immediately it is routed to search service based on the activity that user does. Then after this goes to search service will all get all the data from the catalog service about what service it has. Then user selects an item and then adds to the cart. Then cart service comes into picture. And once user should be able to select the cart, select the service, select the item and tries to buy, then goes the payment service. And then payment service will update the data into the message broker. And eventually once the payment service in itself is a very large scale. So microservices here, they look on a very high level, 30,000 feet. But if we go deeper into them, each microservice has a lot of functionality in it, which takes care of a bunch of workflows in them. Example, payment service itself in itself is a huge product or service as such because it has to work with multiple external providers and ensure that it follows few compliance rules. It follows a few existing each provider's compliance rules and then get the payment done. And it also acts as a rules engine or a decision maker where transaction goes through or it has to be dropped. So that all system is within the payment service. So once the payment is successful, the status of that particular transaction is updated in the message broker, and then appropriately notification service picks up on that particular message and then notifies the user. The notification also doesn't need to be a response. Actually, it would be a response because user is making a API call, right? So this is in general a high level flow of how high level design of how a e-commerce website would look like. Talking about database design for our e-commerce application, we are going to go with a structural database. The reason for that is we are eventually going to have a lot of structured data that we have to get from our database and then use it for our application. Example, there's going to be different microservices that could have separate. So the intention is to have a separate database for each microservice, like user service will have a separate database, and then search service will have a separate database, and so on and so forth. That's the idea here, so that we don't have to tie every service calls to a separate centralized database. That is the idea. So looking at the database design, let's talk about only basic tables that we are going to have. I'm going to talk about the database schema, how it will look like. We are going to have a user table which could have all the user data, which also contains his sessions, and we can use that user data as part of authentication and authorization. And we have a product data. This table is mainly for catalog service where we have all the product data persisted. We have a transaction table. The transaction table takes care of a particular set of transactions that a user makes buying a product or selling a product as such. And the wallet is basically a bookkeeper for all the types of payments that a user could have in one place. So the way we are going to have a structured database is we are going to have a primary key and a foreign key for tables wherever foreign key is necessary. Primary key is a mandatory for all the structured database tables. We could go with any database that we have. Example, MySQL database we could go with, or Postgres is something that we also can look at. But yes, this is the intention of having a structured database with us. And And the latest step, let's talk about how we want to design our APIs, make the basic ones that user could have and will be using in our e-commerce system. Now let's talk about how we want to design our APIs for our e-commerce application. We are going to have a set of only basic APIs that user could have. So user logs into the database, into the e-commerce application, and he could search for a list, search for a particular product that he wants, or he could see some suggestions that are already present on the page. But search is some operation that user if wants to buy a specific product. And from the list, user could select a particular product and he or she could add to cart. That is another API. And once he decides on buying the product, he can mark the product as buy, and that is a post call. And then after that, there could be another post API call where user can add a payment type, because buy internally does in the background payment also. So we don't have to provide multiple APIs to user to say buy and then make the payment. When user says buy in the background, if the user has a particular payment wallet in his or her profile, we make the payment as well. So there's another API that needed is called add payment. Now another API that we would have is add address, because address is something that we would need for the user to be able to post and so on and so forth, right? So when we talk about add address, we should also talk about a specific microservice that we also need to have in our e-commerce, which is called delivery, right? Because after we delivery and tracking, because after user does buy the service, the product, in the background, our e-commerce application is supposed to make sure that there is a tracking service which does delivery and tracking for the product. That is another microservice. This is add address, and yes, these are the basic APIs that we thought of right now. There could be multiple use cases, but these are I've only skeleton ones. But yes, please, suggestions are always welcome. Please suggest if you think of more APIs or more use cases as we would have in a real life uh, e-commerce application, right? Another important component that we could have in our system design is an observability and metrics component. What this does is it collects all the metrics and log collection of the ongoing workflows of the application and provides us the data. And we could have multiple workflows for an observability, having a specific time series database for our developer use case to ensure that we have observability and metrics of the system design. And I've brought up this topic because eventually we would want to have observability and metrics component in order for us to improve on our e-commerce design and make it better.